Hello, my name is Jonathan Ng. I am current final year student of Roseman University, and today I'm going to be giving a presentation on testing C. elegans as an experimental model for dopamine agonist effectiveness in Parkinson's disease. So Parkinson's disease is a disorder of dopamine levels inside of the human body. This is typically seen from older folks that are like over 50 years of age. The human body has the inability to produce and regulate its own dopamine, which is what is mainly believed to have caused these same kind of symptoms, which include bradykinesia, where the person begins to start losing motor function, they begin to start having like tremors, they have a hard time being able to speak, they have gait and walking difficulties, as is commonly known. And one of the reasons of which we have pointed to for this situation has been the action of GRKs, which are the receptors of which are in charge of taking up the dopamine and then being able to have the nervous system be able to regulate itself. Therefore, by being able to figure out that these cellular receptors are the culprits to the current situation at hand, that is one of the reasons of why we believe that through research we have been able to mitigate these symptoms, and we have already been able to do so thanks to that of levodopa and carbidopa, which is basically dopamine supplementation. But by using these drug molecules, we're able to slow down and mitigate the effects of the mental declining of an individual. However, my subject of research today was dopamine agonist, in that the medication designed to activate these receptors, not by supplementing them, because these are second-line medications used when first-line medications are not available. Due to the amount of research that has been done into them to be very minimal, I wanted to make a point and just be able to study these in that of C. elegans. Now, you might be wondering, why would I use roundworms in order to study something in humans? Well, you see, C. elegans has upwards of 41 to 59% genetic similarity to that of human DNA, meaning that this amount, can you imagine, like this amount of human genetic diseases can be exhibited within these little roundworms that are sitting under a microscope. And within these worms, there are two different kinds of GRKs in comparison to humans, which are three different kinds. However, when looking at GRK1 and 2 of these worms compared to the GRK1 and 2s of humans, we found them to be nearly identical. One of the reasons of why I chose this as my model organism compared to that of Drosophila fruit flies, that though Drosophila fruit flies are more common for the genetic diseases, C. elegans is better for this line of investigation. And my experiment was conducted by comparing the activity of C. elegans egg-laying behaviors when treated with different dopamine agonists. The eggs being one of the main driving points controlled by dopamine in that of the C. elegans. I wanted to keep my results as numerical as possible in order to ensure that they were able to be as consistent as possible. Just because while looking at their movement, I wanted to leave as least amount of the study privy to that of interpretation. While with numbers, I was able to graph, as seen down here, to be able to see correlations over time. But when conducting the experiment, I just used 3-day-old C. elegans, three kinds, wild type, GRK1 lacking, and GRK2 lacking, that were treated with different concentrations of the medications pergolide, bromocriptine, and cabergoline. The dopamine receptor activation was measured by the number of eggs laid during the specific time. As stated previously, their ability to lay eggs was controlled by that of their dopamine receptors, which is what I wanted to look at for this, as they were visualized underneath the optical microscope during my own counting and collection of the numbers of the eggs and larvae that were made within that 1 hour time period. So as seen here from pergolide affects both the GRK1 and GRK2s in respective fashion. It was interesting to note that when comparing after 1 hour compared to after 1 day, the differences but similarities as well in the data. For example, with the ones that were lacking the GRK2, one of the dopamine receptors, it seemed to just increase during the first hour in comparison to that of when looking at it a day later, where it would reach some kind of a maximum and then it would more taper off in that its own effect. While also looking at the wild types, the ones that were not genetically altered, they seem to have this kind of increase and then more like a taper off effect that remained constant, as seen from the ones next to it as well. They showed the same kind of correlation. And then with bromocriptine, it got more interesting just because the C. elegans, this receptor, it affected them overall, like both of them, except it would just blindly upregulate, which is one of the reasons of why it's an older medication that is not as used, but it would still seem to have correlation as seen from the wild type, where not only after 1 hour, but after 1 day as well, there was an increase overall with increasing function or increasing concentrations of the medication at hand. And then with carbergoline, which was more predominantly affecting that of GRK2 lacking, it was predictable to note that for the GRK2s, the specimens lacking these receptors, it did not have as high of an effect as, say, what it did with GRK1, where, as stated previously, it had that kind of effect where it would increase and reach an optimal concentration before then tapering off. And then this, as seen, the wild type maintains relatively consistent for both of these specimens, as stated here. So then, in summary, the increase, as concentrations increased in the pergolide, mainly the GRK1s were the most affected by egg-laying rates, as in comparison to that of GRK2s, which hit a concentration and then just decreased in a tapering off kind of effect, while looking at bromocriptine, which had a tapering off effect mainly throughout just all of the switches to the data, with the exception of after the first hour for the wild types and GRK2s, two lackings. And then for the carbergoline, it was interesting to note as well that after 1 hour, it showed just overall increase in comparison to that of after 1 day. Now, for future directions of which this research I would like to see implemented towards would be looking at the overall relationality of the C. elegans to that of human life, in that the C. elegans were 3 days old when they were sexually mature and able to study. But what happened if, in their 4 to 6 week long lifespan, I was to test them at the 2nd week or the 3rd week mark? So that way it could be relational to that of the human, where is typically during later to midlife that these symptoms are typically occur, along with how I would like to explore more into the dopamine agonist just to gain more research overall, just because during the study I was limited to 6 weeks of data collection, and I would like to see how if more numbers and more data was collected on not only just the overall egg-laying behaviors of the worms, but also, as seen from my 3rd point, its overall movement behavior. Though yes, it would be less statistically significant for me to look at that or measurable by that standard as well. I would like to also see how it could have been affected in that part. If you have any questions, please feel free to contact me at the number that was sent to you beforehand, or if you would like to call, just feel free to let me know and I can answer any questions as seen fit. Thank you and have a great day.